Welcome to the DIY Honda Garage channel. The DTC P0970, indicating an issue with the AT clutch pressure control solenoid valve C, has significant implications for the Honda Pilot model years 2016 through 2022. This error occurs when there is an open or short circuit in the electrical system associated with this solenoid valve. The first indication of this DTC is often a failing transmission that may only shift into first, second, or fifth gears due to a fail-safe function embedded in the powertrain control module, PCM. This safety feature prevents further potential damage to the transmission system. Understanding this code requires familiarity with the role of the solenoid, which regulates pressure within the automatic transmission to ensure smooth shifting. Troubleshooting this DTC is crucial, as ignoring it can lead to more severe transmission issues and costly repairs. This guide aims to clarify the troubleshooting steps related to DTC P0970, the solenoid's function, and how to address any identified issues. The AT clutch pressure control solenoid valve C plays a pivotal role in the automatic transmission system by regulating hydraulic pressure applied to the clutch packs, which ensures smooth engagement and disengagement during gear changes. This solenoid is a crucial component hidden within the transmission assembly, specifically located near the valve body. Its operation affects the overall performance of the vehicle, as it directly influences how the transmission responds during shifting. When a fault arises, as indicated by DTC P0970, it can lead to limited gear engagement, with the vehicle unable to shift beyond first, second, or fifth gear due to the fail-safe function of the PCM. The solenoid's electrical circuit needs to be intact for optimal functionality. Therefore, understanding this component's role and location is critical for effective troubleshooting. P0970 is primarily attributed to issues within the electrical circuit associated with the AT clutch pressure control solenoid valve C. The possible causes include open circuits or short circuits that can disrupt the flow of electricity necessary for the solenoid's operation. An open circuit might arise from a break in the wire or a poor connection, leading to the solenoid being unable to receive the signals required for proper functioning. Conversely, a short circuit to ground can cause the solenoid to receive incorrect signals, resulting in erratic or no performance. It is essential to understand that this DTC cannot stem from mechanical failures within the transmission itself, but is strictly related to electrical issues. These potential causes should be assessed thoroughly during the diagnosis process. The symptoms associated with DTC P0970 are often apparent to drivers experiencing transmission difficulties. The most notable symptom is the limitation on gear shifting, where the vehicle may only engage in first, second, or fifth gear. This limitation is a direct result of the fail-safe function triggered by the PCM to prevent further transmission damage. Drivers might also notice that the transmission struggles to shift gears smoothly, leading to a rough driving experience. Often, the check engine light will illuminate on the dashboard, serving as an immediate alert for the driver to seek diagnostic attention. Additionally, the vehicle may exhibit erratic behavior during acceleration, which can further signal underlying issues involving the AT clutch pressure control solenoid valve C. Recognizing these symptoms early is crucial for timely diagnosis and repair. In the first troubleshooting step, begin by turning the vehicle to the on mode, which allows the system to power on without starting the engine. This step is essential, as you will be using the HDS, which stands for Honda Diagnostic System, to interact with the vehicle's onboard computer systems. Once the vehicle is in the on mode, utilize the HDS to clear any current DTCs, including P0970. This action will reset the diagnostic system and enable you to see if the code reappears. After clearing the code, check the vehicle again for any pending or confirmed DTCs with the HDS. If DTC P0970 reappears, it confirms that the failure is persistent, and you will need to proceed with further diagnostic steps. If the code does not reappear, it suggests an intermittent electrical fault, which requires checking the connections and terminals for issues such as corrosion or looseness. For this step, start by ensuring the vehicle is turned off and in the lock mode. This is crucial before performing any electrical checks to avoid any accidental shorts or damages while handling the wiring. Next, you'll use the HDS to jump the SCS line, an abbreviation of the service check system, for more than 1 minute. This process allows the diagnostic tool to run checks on the connected systems. After completing this, disconnect the PCM connector B51P, which is vital for further testing. With this connector removed, you will perform a continuity test between specific test points to assess the integrity of the wiring. This test ultimately helps to determine whether there is a short circuit within the LSC line, leading to the next diagnostic step based on the test results. In this third step, begin by disconnecting the AT clutch pressure control solenoid, valve C2P connector, which is essential to isolate the solenoid from other electrical components. The vehicle must be in the off/lock mode during this procedure for safety reasons. After removing the connector, you will perform a continuity check between specific test points using a multimeter. This involves checking between the AT clutch pressure control solenoid, valve C2P connector, terminal number 2, and body ground. If continuity exists, this indicates a short to ground in the LSC wire, meaning it needs urgent repair as it is causing the fault. Should there be no continuity, it suggests that the LSC wire is intact, leading to the conclusion that the AT clutch pressure control solenoid valve C itself may be faulty, necessitating replacement of the secondary valve body. Continuing with the diagnostic process, this fourth step requires you again to disconnect the AT clutch pressure control solenoid valve C2P connector. As established previously, it's vital to perform this whilst ensuring the vehicle is off/lock to maintain safety during the testing process. You will check for continuity between test points, specifically between the AT clutch pressure control solenoid valve C2P connector, terminal number 2, and the PCM connector B51P, terminal number 8. This test is critical as it will determine if there is an open wire condition between the solenoid and the PCM, which could lead to the DTC being stored. If continuity is present, it confirms that the wiring is intact, allowing you to proceed to the next diagnostic step. However, if continuity is absent, this indicates an open in the LSC wire that needs to be repaired to restore proper function and eliminate the DTC. Moving on to the fifth troubleshooting step, the focus shifts to checking the continuity of the LSC PG line. As with previous steps, it is important that the AT clutch pressure control solenoid valve C2P connector is still disconnected and the vehicle remains in the off/lock mode. During this test, you will check for continuity between the AT clutch pressure control solenoid valve C2P connector terminal number 1 and body ground. A positive result here means that the LSC PG wire is functioning correctly. If no continuity is detected, it suggests that there is an open in the LSC PG wire, which needs attention. In such cases, you must repair this wire, ensuring that it properly connects the solenoid valve C to ground, specifically the G101 ground point, which is critical for the solenoid's proper operation. Maintaining a solid ground connection is essential for electrical components to function effectively. In the final troubleshooting step, you will need to measure the resistance of the AT clutch pressure control solenoid valve C. This involves checking between the solenoid's connector terminal number 1 and terminal number 2. As you perform this test, Ensure that the vehicle is still in the off lock mode, with the connectors disconnected for accurate measurements. The expected resistance should fall within a specified range of 4.7 to 5.9 ohms. If the measured resistance falls within this range, the AT clutch pressure control solenoid valve C is functioning correctly, and the next course of action should be to replace the PCM, since it could be the source of the problem. If the resistance is outside this specified range, it indicates a defective AT clutch pressure control solenoid valve C, necessitating the replacement of the secondary valve body to restore proper transmission operation and eliminate the DTC. Upon completing the repairs associated with DTC P0970, it is to mitigate the risk of encountering DTC P0970 or similar transmission-related issues in the future. Engaging in regular preventive maintenance is essential. Conduct routine inspections of the vehicle's electrical systems, particularly focusing on connections and wiring harnesses associated with the AT clutch pressure control solenoid valve and PCM. Checking for signs of wear, corrosion, or loose terminals can prevent avoidable faults from arising. Additionally, replacing components that show signs of damage or degradation promptly contributes to the longevity of the transmission system. Keeping the vehicle in optimal condition through these practices not only enhances reliability, but also saves substantial repair costs long-term. A proactive maintenance approach ensures that your Honda Pilot remains in good working order and minimizes unexpected breakdowns. In conclusion, understanding DTC P0970 and its implications on the Honda Pilot's transmission system is essential for both mechanics and vehicle owners. The systematic approach outlined in this guide ensures that technicians can effectively diagnose and address the issues related to the AT clutch pressure control solenoid valve C. It is crucial to remember that this DTC is electrical in nature and unrelated to mechanical failures, which changes the troubleshooting perspective significantly. Implementing preventive measures, such as regular system inspections and maintenance, can extend the lifespan of vital components and promote smoother vehicle operation. Ultimately, a proactive strategy will greatly enhance the owner's experience and satisfaction with their Honda Pilot, ensuring it remains reliable on the road. Please like and subscribe to the channel. See you next time.